Today we're going to talk about derivatives and partial derivatives. So let's do a couple of derivative examples. Say we have an equation, like this example 1. So f of x is equal to x squared plus 3x plus 2. And then the question asks, what is the derivative of f of x? Okay, so we're going to take the derivative of our f of x. So how do we take the derivative? If we have x to the n power, right, and then we take the derivative of it, we get nx n minus 1. So let's do the same here. We take the derivative of f of x. Our x squared, or 2, is going to come down, 2x, and then 2 minus 1, so 1, which we don't have to write, but it's there. Plus, now here we have a constant of 3. We have a 1 here. It's just, we don't write it, but it's understood that it's there, so that 1 comes down. So 3 times 1 is just 3. 1 minus 1 is just 0, and anything to the power of 0 is just 1, so we get 3. Plus 2, derivative of a constant is just 0. So, and we can rewrite this simpler as 2x plus 3, and that's the derivative of the original function. Now, example number 2. Let's do f of y this time. Y to the 5th minus a plus y cubed plus 3y. Okay, so here we want to take the derivative of f of y. So again, everything that's a power comes down. So 5 minus a, all of it comes down and is now multiplied by our y variable. Now, our exponent, we minus it by a 1, right, just like we have here, plus y cubed, the 3 comes down, and then the power becomes subtracted by 1, so 2, plus 3. So what happened here is that we have a power of 1 on the y. It came down, and then 1 minus 1, 0, so we just get a constant. We can simplify this here by subtracting the 5. 5 minus 1, so 4 minus a plus 3y squared plus 3. So that would be the answer. So the answer for the first one, this, answer for the second one, you get this. Now, what about partial derivatives? Partial derivatives occur, example 3, whenever we have a function that has two separate independent variables. So an independent variable is the variable that's constantly changing in a function. In the case of example 1, our independent variable was x. In example 2, independent variable was y. So what do we have? Two of them. A function that is f of x, comma, y. And then let's make up a function 3x squared plus 5y plus 3xy. And then I say, okay, we need to take the derivative. We can't take the derivative if we don't know what we're taking the derivative with respect to. So we can either take the partial derivative with respect to x, or the partial derivative with respect to y. And partial derivatives are denoted like this. The partial derivative with respect to x and the partial derivative with respect to y. It's not a 2, it's a partial. So let's do partial derivative of f, the function f, with respect to x. So what that means is that we're going to take the derivative of this function, but we're going to treat y as a constant for this particular case, because here we're only concerned with x being an independent variable, not y. So anytime we see an x, we'll take the derivative regularly. Anytime we see a y, we'll take it as if it's a constant. So if we look at the first part here, take the derivative, so we bring the power down. 3 times 2, 6, x to the power of 1. Now this one here, 5y, is treated as a constant because there's no x. So derivative of a constant is 0. And then lastly here, 3xy, we have two constants, the 3 and the y, and we have one independent variable x. So we get 3y. Derivative of x is just 1, so we're just left with 3y. And that is the answer for the partial derivative of f with respect to x. Okay. So now we're going to do the same thing, but with respect to y. Okay, so partial derivative of f with respect to y, we look at the first variable. There is no y's, and we're now treating y as the independent variable only. So all of this is treated as a constant. So it becomes 0 plus 5y. We take the derivative of it, we just get 5. And then lastly, 3xy. We take the derivative of y, which is 1, so we get plus 3x. And we can actually rewrite this one and this one without the 0, so 6x plus 3y, and this one would be 5 plus 3x. And these are the simplified answers for both partial derivatives.